This is an interesting question that involves a little bit of logarithm, an exponential, and quadratic equation at the same time. Let's work on this one. The question is saying ln x the whole square minus ln x square minus 63 is equal to 0. So we need to find out what is the value of x here. Here, this part is ln x, the whole square. It means ln x multiplied by ln x. But on the second one, it's ln x square. It means 2 times ln x. Then minus 63 is equal to 0. Ln or any natural logarithm x square is 2 times log x, or simply log a to the power of b is equal to b log a. This is just a rule, a given rule. But if we have to log, say log a multiplied by, say again another log a itself, multiplied by itself, log a, it means log a the whole square. It's different from log a square. Here is the other fact. These are the two facts we're applying in this equation. Now, before we continue, we need to see the characteristic of this equation. We have got 2 ln x here, 1 in here. More or less, it looks like a quadratic equation after a certain substitution. Let's use a substitution, say later y is equal to ln x. In this case now, it's going to be like y square minus 2y, we have 2 here, minus 63 is equal to 0. The objective in here is to solve for y, and then we go back to our substitution in here to find out for the value of x. Y squared minus 2y minus 63 is equal to 0. Y squared minus 2y minus 63 is equal to 0. This is a quadratic equation with a general form, so we need to find out the coefficients in a constant term. A is equal to 1, which is a coefficient of x squared. B is equal to minus 2. C is equal to the constant term minus 63. Let's find out first the discriminant part, b squared minus 4ac. As we may remember, the general formula is minus b plus or minus square root of b squared minus 4ac over 2a. To just sort out b squared minus 4ac will give us a little bit of hint on the characteristic of the solution set to be a real root or a perfect square or a complex number. And then it clarifies the next steps by avoiding unnecessary writings of the b squared minus 4ac again and again. Let's see that one. B squared is minus 2 squared, which is 4, minus 4, a is 1, which is here, and c is minus 63. 2 negatives in here will make the sign a positive up here. 4 times 62, 252 in here, and we have a 4 in here, which is 256. Very good. Now, the solution set y is equal to minus b, negative of negative 2 is just a 2, plus or minus square root of b squared minus 4ac is already done here, 256, divided by 2a, 2 times 1 is 2. 256 is a perfect square, which is 16 square. 16 square is 256. So we can take 16 for this value. So y is equal to 2 plus or minus 16 divided by 2. The two cases are 18 divided by 2, or the other case is minus 14 divided by 2. So y is equal to 9, or y is equal to minus 7. Now we have y. We still need to work on the x value. We need to remember what the substitution we've made there, which is y is equal to ln x. Y is equal to ln x, which is equal to 9. This is one part. The other one, ln x is equal to minus 7. Ln x is just a natural logarithm x with a base e, where e is roughly 2.71. But we don't need to use the estimation here. We just use a letter a. We're at a point where log x to the base e is equal to 9, or log x to the base e is equal to 7. Let's go on that one. Log x to the base e is equal to 9, or log x to the base is equal to 7. In this case, minus 7 actually here, not 7. It's minus 7 up here. In this case, when we convert this logarithmic format into the exponential, we go in such a way that e to the power of 9, we go from here to here, is equal to x, or same way here, e to the power of minus 7 is equal to x. This is just, again, an exponential to logarithmic conversion. It is a very common one and a must to know. Log y to the base, say b is equal to a. If we say this, which implies b to the power of a is equal to y. We can convert from exponential into logarithm, and from logarithm into exponential to solve problems. So this is just applying a formula here. So e to the power of 9 is equal to x, or e to the power of minus 7 is equal to x. So these are the two solution sets, and when we go back to the original question, yes, we have e to the power of minus 7 as a choice, but we don't have e to the power of 9. So the correct answer is going to be D, because the answer is e to the power of 9 or e to the power of minus 7. Thank you for watching.